Hello, continuing our work with arithmetic series, so adding up a bunch of terms that are in an arithmetic or linear pattern. We're still using our formulas from page 22 in our log tables, and we're going to jump into a slightly more complicated question here where we really have to read the English at the beginning quite carefully. So the sum of the first 10 terms in an arithmetic pattern is 120, and the sum of the next 10 terms is 720. Find S of n, and if S of n is equal to minus 24, what is the value of n? So we have lots of steps in here, so let's write down the information that we've got. The sum of the first 10 terms is 120. So S of 10 is the sum of the first 10 terms, and I know that I'm dealing with a linear or an arithmetic pattern, so I'm going to write down my formula here. So I'll write that down first and then sub in n is 10. So the second that I see that I'm dealing with a series, a linear series or an arithmetic series, I'm instantly going to write down my formula from page 22 in my log tables. That gives me an anchor for what tools are available to me. And I'm told about S of 10. The sum of the first 10 terms would be S of 10. So I sub in n is 10. I'm told that that's 120. Well, let's tidy this up a little bit. 5 on 2a plus 9d is equal to 120. I recognize that I could divide both sides by 5. So I end up with 2a plus 9d is equal to 24. Now I've ended up, not by knowing exactly where I was going to go with this question, but simply by working with the information that I am given, I recognize that I'm almost certainly dealing with simultaneous equations, because I've ended up with an equation in A and D. I've ended up with one equation with two unknowns. So I probably am going to deal with simultaneous equations. So where's my next equation going to come from? Well, if I look at the other information given to me in the question, the sum of the next 10 terms is 720. The next 10 terms. Well, I'm starting at, I have the sum of the first 10 terms, so I'm going up to S of 10, and then the next 10 terms would bring me up to S of 20. But I don't have a formula for going from 10 up to 20. I only have a formula going from n is 1 up to 20. So thinking about this, I know that going from the sum of the first 10 terms up to the sum of the first 20 terms is the formula that I need. So the sum of 20 minus the sum of the first 10 is the information I'm actually given. That's 720. Going from the first 10 terms up to the next 10 terms is 720. That's the information I'm given in the question. But can I make that into an equation I can easily work with? Well, I know what the sum of the first 10 terms is. It's 120. So sum 20 minus 120 is equal to 720. Rearranging that, I get the sum of the first 20 terms must be 840. And now I'm back to something that I can use my standard equation for. So let's do the same steps here and see if I can get another equation in A and D, because now I recognize I have two equations and two unknowns in one equation. I'm recognizing that I'm probably doing simultaneous equations in A and D. Let's see if I can get another one using this formula now. So I have S of 20 is going to be 20 all over 2 on 2a plus 20 minus 1 on d, and I now know that that is equal to 840. So I end up with 10 on 2a plus 19d is equal to 840. Again, I recognize I can divide both sides by what's multiplied here to get rid of my multiply. I could multiply this out and then redivide by 10, but if I can spot it earlier, it means I have less work to do. Okay, so I now see clearly that I have simultaneous equations, so I'm going to call this equation 1 and equation 2 to keep track of things more easily. And I am going to, in this case, life is easy. I have 2a here and 2a here. So if I start with equation 2 and subtract away equation 1, I'll end up with an equation only involving d. So equation 2, 2a plus 19d is equal to 84. 2a minus 9d is equal to minus 24. Subtracting or adding these two equations together, I end up with 10d is equal to 60. Dividing both sides by 10, d is equal to 6. Now I need to find the value of a. That's easier to do with equation 1. Because the numbers are smaller, but you'll get the right answer if you sub into either of them. It's just always go for smaller numbers if you can, because you're less likely to make mistakes with smaller numbers. So I have 2a plus 54 is equal to 24 minus 54 from both sides. 2a is equal to minus 30. A is equal to minus 15. Now I was asked for S of n. I now have d and a, so I can just sub into my formula. S of n is equal to n all over 2 on 2a plus n minus 1 on d. N all over 2 on 2 by minus 15 plus n minus 1 on 6. When I tidy that down, I will get 3n squared minus 18n. So that's just multiplying out. We end up with 3n squared minus 18n is my formula for the sum of the first n terms. And then the second part of the question, I'm asked for if S of n is equal to minus 24, what is n equal to? So I'm just going to do that substitution. 3n squared minus 18n is equal to minus 24. When I do that substitution, I recognize that I've just got a quadratic equation. So rearrange like a normal quadratic equation, get everything over on one side. 3n squared minus 18n plus 24 is equal to 0. I recognize that I have a common factor of 3 for everything, so I can just divide that out. N squared minus 6n plus 8 is equal to 0. Factorize this in the normal fashion, and you will find, when you do that out the normal way, you will find that you end up with n minus 4 by n minus 2 is equal to 0. So n minus 4 is equal to 0, n minus 2 is equal to 0. N is equal to 4, n is equal to 2. Now, a lot of the time when we do these kind of questions, we'll find out that one answer is invalid. But in this case, both answers for n are valid numbers. We haven't ended up with a negative solution. So both of these answers are valid. So what is going on? Well, if we look at our series, we know that a is 15 and d is a is minus 15 and d is 6. If you remember that these are first term and difference for a arithmetic pattern. So minus 15 is my first term, add 6. And my second term is going to be minus 9. My next term is going to be add 6 is minus 3. My next term is going to be add 6 is plus 3. My next term is going to be add 6 is going to be plus 9. So this is T1, T2, T3, T4, T5. So what's going on that if my sum ends up minus 24? Well, if I get S of 2, which would be n is 2, that would be minus 15 minus 9. The sum of the first two terms is minus 24. And S of 4, the sum of the first four terms, would be minus 15 minus 9 minus 3 plus 3, which also adds up to minus 24. So both solutions are valid. Both n is equal to 2 and n is equal to 4 gives us the sum going up to minus 24. So that's the valid question. The last thing remaining with series that we want to touch on is just a way of writing this that is going to be useful in certain parts of the course and we're supposed to know about it. So if I take a fairly straightforward type situation like Tn is equal to 2n plus 4. So this is a normal term from an arithmetic or a linear pattern or a sequence. So this is back to a normal Tn, nothing unusual happening. A way of writing the sum of the first n terms is to use something called sigma notation. This is capital sigma. It's a Greek letter. And I'm going to write this down and then show you how it works. So the way that we can write a sum or a series is like this. Sorry, that should say or, not n. The way that we read this is the sigma means add up. The thing that looks like a capital E means add up our terms. So this means, to read it out in English, start at or is 1. So we have our pattern is 2 or. 2 or plus 4 is our T or instead of Tn. So start at n is, or is 1, and add up all of the terms until you get to n. So what would this look like in practice? It means start at or is 1, so 2 on 1 plus 4 is our first term, and then the sigma means add up, so sum up 2 on 2 plus 4. This is our first term. This would be T1, T2, T3, 2 on 3 plus 4, and so on. The pattern just continues up until n. So that's just going to give us 6 plus 8 plus 10, and so on, up until we get to 2n plus 4, our nth term. So this is just another way of writing the sum, the series notation. So this formula gives the same result as this notation here. It's just a different style of writing it. So we start at n is 1, or is 1 as we've written it here, and add up our terms up to the nth term. So it means exactly the same thing as what this formula ends up meaning. It's just a different way of writing it. And that's what we need for arithmetic or linear series.